Hey everyone, welcome to week 14. This is assignment 22, which is on the division algorithm. So it relates to Cant-Buck problems, and I've highlighted some of the conjectures we've developed so far. So the first thing is the cheapest item can be purchased at CantMath with the denominations of m and n is the greatest common factor of m and n. So it's the largest number that divides into both of those, right? So we've seen that, like when the denominations were 4 and 7, the biggest number that divides into both of them is 1. So the cheapest item that can be purchased is 1. Or we saw one that was denominations of 6 and 9. The biggest number that goes into both of those is 3. So the greatest common factor is 3, and therefore that's the cheapest item that can be purchased. So now if you have a question that asks for the cheapest item, just find the greatest common factor, right? The biggest number that goes into both numbers. Once you know that, then we know that all items that can be purchased at the Cant-Math are multiples of that greatest common factor. So, and we even found a way to write an exchange equation for anything by multiplying that cheapest exchange equation through by a value, a factor. So for example, let's say we have the denominations 6 and 9, then the cheapest item we know is the GCD, which is 3. And so then any multiple of 3 can be purchased, 3, 6, 9, 12, 15, etc. Okay, so here's another example to try. Just getting that idea again. So what's the cheapest item that can be purchased? You can just find the greatest common divisor and then list the 5 cheapest items that can be purchased, right? Just multiples of that greatest common divisor. Okay, so that's a little practice with those conjectures at this point. Okay, and then we get a little mathy going on from here. We get to what's called the division algorithm. So given positive integers a and b, and let's just make b the bigger one, there are some whole numbers q and r such that we can write this equation, b equals qa plus r. Okay, so I did an example here. Let's just come up with some numbers like a is 13 and a is 3, b is 13. Can you find numbers such that we write that equation b equals qa plus r? Well, what you can think of with these is that a is the divisor, b is the dividend, q is the quotient, and r is the remainder, right? So that means if you, in this example, take 3 and divide it into 13, that's what I'm talking about with the divisor and the dividend, that goes in 4 times with 1 remainder, right? So there's your q, and there's your r, and then there's your a and your b, right? Which it works out, right? Because now we have this equation, b equals q times a plus r. 4 times 3 plus 1 is 13. So in summary, I have a little table here. I have the q, the r, and then I can write the division algorithm equation. Okay, so you're going to try that with the next page. You just have some different a's and b's. So you can do that one just like I did this one, right? Do some division, figure out the quotient and the remainder, and then write the overall equation. Okay, so there's some of those to practice. Finally, the last thing in this assignment is proving a conjecture. So we've had this claim before, let a, b, and c be integers. If a divides both b and c, then a divides the sum b plus c. Okay. Is that even true? And if so, can we prove it? So in a past assignment, we did experiment with that, and we made a conjecture that it seems to hold true. We could not find a counterexample. And we made a little explanation of why we think it's true, but now we would like to do an official mathematical proof of it. And so I'm going to go ahead and do that now. So in the proof, we know that a divides both b and c, right? So I would just write that here. Basically, that's just a restatement of the claim, the if part of the claim. We want to show that a divides the sum b plus c, right? Okay, So if A divides both integers B and C, then by using the definition of divides, right, from the previous assignment, then there's some integer Q, right, such that A times Q, or Q times A, is equal to B. And then there's another integer, since A divides C, P times A would equal C, right? So we have Q times A equals B, and P times A equals C, right? That's what it means for A to divide B and A to divide C. There's some number you can multiply A by to get B and to get C. Now we can combine those, because what does the sum B plus C look like? So B plus C by substitution, okay, B, we wrote it as Q times A, and C, we wrote it as P times A. Okay. So I'm just doing substitution of those little equations I wrote in the previous paragraph. Now using a little algebra, notice both of those have an A. So I'm going to factor out the A. And I'm left with Q plus P. Right? But Q plus P, or P plus Q, is also an integer. So look what we've written. We've written B plus C as A times some integer. Right? So that means A divides B plus C. That's the definition of divides. If you can write A times something equals B plus C, that means that A divides B plus C. Hence, we have shown that A divides B plus C. This would be an official mathematical proof with no numbers, just using the definitions and some algebra and a little logical progression to show it. Okay, so try that one. This one's very similar, but it has a little bit more to it, because A divides three things: 10, B, and C. Then show that A divides B plus C plus 10. Honestly, what you can do is just follow this thing and just pretty much rewrite that, right? But adjust it to match this problem. Okay, so hopefully that helps with this last example. Okay, so that's assignment 22. When we get to assignment 23, we're going to experiment with some common divisors. So doing a lot with division here at the end of the class. So our idea here is we're trying to develop one more tool that involves positive integers and dividing. Okay, so here's an example to get us started with some experimentation that will lead us to a conjecture or a tool. So I'll get you started on this one. Suppose you have two numbers, 40 and 60. We want to compare the common divisors of A and B, and then also the common divisors of A and B minus A. Okay, what? Okay, if you just go back through these steps, it'll lead you in the right direction. So the first thing is just list the divisors of 40. By divisors, we're talking about all of numbers that divide evenly into 40. I'll get you started, right? 1 for sure. 1's always going to be on your list. 2 would work, right? Because 2 goes into 40. 2 goes into 40 20 times. 2 times 20 is 40, right? So you're just going to make a list of all of them. 3 doesn't work. 4 works. Keep on going, right? So make your entire list of divisors of 40. Okay. Same for the next one, divisors of 60, right? Just make your common, and make your list. You want to get all of them, right? I mean, when you do, by the time you get to the last one, it should be 40. By the time you get to the last one, it should be 60, right? Because 60 goes into itself, 40 goes into itself. You're filling in the blanks. Figure out all of the numbers that divide evenly into 40 and 60. Okay, next step, list the divisors of the difference between those two numbers. 60 minus 40 is 20. So here your list is going to be all of the divisors of 20. 1 and 2 again are on the list. Any other numbers, and your last one's going to be 20, you fill in the middle. Okay, all numbers that divide evenly into 20. Okay, and then next it's asking for the common divisors. You have these lists. Now, what do they have in common, right? So list the common divisors of the first two, 60 and 40. So you have two lists. Here, it's just going to be all the numbers that are in both of those lists. Okay, it must be in both. So obviously 60 would not be on your list of common divisors. 1 would be on your list of common divisors because 1 is in both lists, right? So all of them that are in both, list them there. Same kind of thing going with E, but now it's the 40 and the 20 list. So A and C. What do those have in common? Make your list. Okay. Finally, what's the GCD? When you see GCD, it's the greatest common divisor. Greatest common divisor of 60 and 40. All right. That would just be the biggest number that's in your list of here of common divisors, right? It's the greatest one in your list. So what is the greatest common divisor of 60 and 40? And then the greatest common divisor of 40 and 20. What's the biggest number you have in this list? Okay, so hopefully that makes sense or helps to navigate those questions. And then you're just going to try it with some other examples. Here it's more in a general way, but these questions here are the exact same that were just asked previously, right? So just with new numbers, A is 35 and B is 49, but you can go through all of those. And then the last one, just choose your own A and B, and then go through those same steps, listing divisors, subtract B and A, common divisors, and finally the GCD. Okay, so these will look very much similar to the ones that you did previously. When you choose your A and B, I would just choose 2 numbers that have some common divisors that are other than 1, or else it just doesn't really do a whole lot to make our conjecture. So try to think of 2 numbers that have some similarities, have some divisors that are in common, and then it'll be more fun that way. All right. Okay, hopefully that helps with this week's material. Then there's also a discussion post, and that's it. And again, feel free to send questions my way if you get stuck or if you're unsure of something, feel free to ask. Okay, hope you have a good week 14, and I will see you next week. Thanks. Bye.